So, in the last lecture, I think before 15 days ago, we have started with the chapter number 4, okay, which was energy action planning, monitoring, and targeting. So, mainly in this chapter, there are three sections, okay. First starts with energy action planning, then energy monitoring, and after that, the last part that is the targeting, and after that, some analysis is there, cumulative analysis, okay. So, after that, the chapter will be over. So we have already started with energy management systems. Okay, the successful pillars or the four stages of energy management. Then we have seen the steps in energy action planning. Then we have seen the top management commitment and support. After that, we have seen the energy manager responsibilities and duties assigned under the Energy Conservation Act. Okay, so we have seen responsibilities also, duties also. Today we are going to see what is energy monitoring and targeting. Okay, after that we are going to see the elements and we are going to see the data and information analysis. Okay, so we will start with the energy monitoring and targeting. So basically, this energy monitoring and targeting is a management task. Okay, management task means either we have to make the optimizable form or we have to make the reduction in the usage and make the system optimal. Okay, that is nothing but the management task is all about. Okay, so already they have seen it is a management technique that uses energy information as a basis to eliminate waste. Okay, now here energy information is nothing but the energy consumption data, okay, per year, per week, per day, or per month, etc. On a basis to eliminate waste, then reduce and control current level of energy use. Okay, current level means the level which is at the right now. Okay, like a real time level, and improve the existing operating procedure. Okay, now improving the operating procedures is nothing but the changing in the design or change in the energy flow. Okay, so now here there is a line, okay, which we are going to see. You can't manage what you don't measure. Okay, so this is very important line as far as the energy monitoring is concerned. Now this line I can explain you. Okay, so in order to manage or control a particular thing, you have to know the exact measurement of the particular thing. Okay, for example, if you are going to conserve or if you are going to control the energy flow or you are going to maintain the energy flow, for example thermal or electric energy, then you have to be aware of the energy measurement. Okay, you cannot access or you cannot control the energy without the measurement of energy. Okay, so for example, if you are going to control your monthly expense, if you suppose your salary is 50,000, you are going to save the salary, you have decided to save the salary per month. Okay, per month you are going to decide 20K to save. So now for that purpose, you need to have information regarding your salary. Okay, the amount of salary, then what is the amount in your bank present, and what are your investments. So these measurements are required in order to save your salary, otherwise you cannot save it. Okay, likewise energy conservation or monitoring also require the measurement of energy in order to save it. Okay, so it is essentially combines the principle of energy use and statistics. Okay, so energy usage and statistics means the data which is available after the consumption of energy. Okay, recording of the energy. So now we are going to see what is the importance of energy monitoring and targeting. Okay, with concern with the thermal energy and electric energy conservation. Okay. Okay, so please unmute your mic. Sorry, mute your mics. Okay, so we are going to see the comparison first of all. So basically, energy monitoring and energy targeting both are different concepts. Okay, here energy monitoring includes the observation of the pattern of energy flow or energy consumption. So in case of energy monitoring, you have to observe the pattern or the what you called as structure of the energy consumption at your organization. Okay, and energy targeting is different. It is the real time energy consumption level. Okay, means you have to measure and you have to identify how much energy consumption is going on at a real time. So both energy monitoring and energy targeting works on real time analysis. Okay, it is not expected to work on predictive and future time. Okay, or backward time. You have to work on real time. For example, if you are going to monitor a particular energy flow in your industry, then you have to monitor it for a present time. Okay, suppose you are going to monitor for a month, you have to monitor from day 1 to day 30. That's it. Okay, and you according to the monitoring, and you have to see the process flow, you have to establish the pattern of the energy consumption. Okay, after that you have to set some targets. Okay, which comes under targeting. So monitoring is observing and targeting is the measurement and identification of energy consumption. That's it. This is the basic difference. Now we are going to see what they have seen. So monitoring and targeting is a management technique already we have seen, in which all the plant and building utilities such as fuel. Now here plant utilities and building utilities are different. Okay. So plant utility matlab the things which are required, okay, for the end product, like fuel, okay, then steam, then refrigeration, compressed air, water, effluent, and electricity. Okay, now here there are two different parts, if considered. Now there are two different parts like plant and building utilities. Now here plant consists of the most important thing, that is the input. Okay, like the fuel can be of different types like diesel, LPG, okay, coal, etc., electricity, etc. Okay, there will be steam also for steam power plants or steam turbines, etc. Then refrigeration. Okay, if there is a storage plant, okay, for storing of the fruits and different eatable things, for that purpose. Compressed air, okay, then water is also a type of raw material or a input source, and electricity. These are the plant concerned utilities. And the next is building utilities, okay, which are raw materials, okay, then finished product inventory, then building occupancy, then personal and capitals. Okay, personals and capitals means these are the terms are financial terms. Okay, so both are important in case of monitoring and targeting. Okay, both, which means building and plant utilities both. Okay, now here the most thing, the most important thing for any organization or industry is the building things, okay, which are the raw materials, okay, then the finished product inventory, which is the end product, then occupancy, then capitals, okay, financial capitals, etc. Now in case of energy monitoring, both the things are given the same importance, like building utilities also and plant utilities also, okay, which are plant inputs, which we have seen fuel, steam, etc. So in next is, now we are going to gather all the information like monitoring of energy, and then the actual real time measurement and identification of energy. So after that, once the information is available on a regular basis, we can set some targets. Okay, target, for example, suppose if you are going to monitor a particular industry for one day, and suppose that in that one day there is a consumption of 2 kilowatt hour. So now you have to set some targets in order to reduce the energy consumption So now what we are going to do, we are going to set some target at 1.5 kilowatt to 1.7 kilowatt hour. Okay, so 10 to 20% less than the actual. So that can be done. Okay, now here there are variances. Okay, variances are nothing but variations in the output. Okay, at some day there will be different output. Okay, at some day the consumption will be 5 kilowatt, at some day it will be 1 kilowatt, at some day it will be zero point 0.5, at some day it will be 10. So according to that your target should change. Okay, that is nothing but the variances. Okay, it can be spotted and it can be interpreted according to the remedial actions. Okay, we can take remedial actions in order to, variances are nothing but the error matlab kya, the difference between the output and the desired value. Okay, so we can reduce it by making some remedial actions. Okay, and implement it. And the last thing, what is the use of energy monitoring and targeting? Okay, in case of industry, is it really implicable or is it really advantageous for the industry? So yes, so here they have written, the monitoring and targeting programs have been so effective that they show typical reductions in annual energy cost. So our ultimate goal of this energy monitoring and targeting is to reduce the annual energy cost, okay, in rupees, lakhs or crores, etc., depending upon the energy consumption. So in various industrial sectors between 5 and 20%. So there has been a significant amount of reduction in the annual energy cost for different industries when they are going to perform energy monitoring and targeting. Okay, so what is the reduction? That is, it varies from 5 to 20%. So now 5 is the lowest, 20 is the highest for this case. If you are going to implement it very well manner, then you are going to achieve 20% of energy cost. Okay, reduction in energy cost. That is very advantageous and very financially reasonable for any industry and top management. Okay. So now next is, I think you have understood with the need of energy monitoring, what is energy monitoring and targeting, and what are the uh, advantages. Okay, there are no disadvantages of these techniques. Okay, these are all concerned with the energy cost reduction per year or per 6 months or quarterly, etc., depending on the industry. Now here next is elements of energy monitoring and targeting. So what are the different parts, or you call it as elements of the energy monitoring and targeting system that we are going to see? So there are seven number of hmm, there are seven number of energy or seven number of elements of monitoring, okay, of energy and targeting of energy. So we will see one by one. First is the recording. So as I said earlier, energy monitoring is nothing but observing or determining the flow, process flow or pattern of energy consumption. Now here, for to observe or to analyze the or to see the pattern, we have to record it. Okay, so recording is very essential. So first is recording. In this recording, it includes measuring and recording energy consumption. Okay, first of all you have to measure the energy consumption per hour, per week, per day, etc., etc., and you have to record it. Okay, record means you have to export the data in CSV files, Excel files, JSON files, etc., okay, which can be used for further analysis. Okay, next is analyzing. Okay, next important thing is analyzing. Analyzing is a very crucial term, okay, which is very important because whatever the data that been gathered from the recording devices and measuring devices needs to be analyzed, okay, in an optimal way. The data needs to be clean first of all, okay, and it has to be analyzed. For example, you can use machine learning here for analyzing the data, okay, so CSV files. So for that you have to see whether the problem is a classification problem or regression problem. You can use different algorithms of machine learning like logistic regression, okay, multiple linear regression, naive Bayes techniques, and AdaBoost, etc., etc., okay, depending on the type of problem it is. You can also use deep learning if possible. Okay, So also you can also use convolution neural networks, artificial neural networks for that computation purpose, for analyzing of the data. Okay, so that is the data part. Next is comparing energy consumption to an appropriate standard or benchmark. Okay, now here standard or benchmark. Okay, it concerns with the targets. Suppose that there is a policy, national policy. They have chosen a particular target to save this much amount of energy supply, energy consumption cost per year, so on, so on. That can be met by using the comparison technique. Otherwise, you have to set some targets. Suppose your consumption for a day is 1 kilowatt. Okay, you can set a target that the consumption to be downscaled by 0.2%, 0.5, 0.1, 1%, 10%, etc. Huh? That can be done by comparing. Okay. Next is setting targets. As I said earlier, you have to set some targets respective to the analyzing and comparing. Okay, data. Whenever the data from these two things are gathered, then we have to set some targets. Hmm? That the targets may be quarterly, yearly. Okay. Suppose monthly bill, electricity bill of industry is 10 lakh, then you have to set target that it should be around 7 lakh to 9 lakh. Okay, at least 1 lakh should be the saving, and so on. Okay, next is monitoring is also very important. Okay, which that is an essential part. Monitoring basically includes the recording and analyzing. Okay, recording means measuring and analyzing means understanding the flow and pattern of the energy consumption. Okay, next is reporting. Now here there is a term called variance. Already we have seen variance. Okay, variance here we have seen. Variance means nothing but it is an error or a difference between the actual value, okay, and the desired value. Hmm? So now here we have to report the variances to the top management. Okay, okay. First of all, we have to report the results, like results from monitoring, then comparing, analyzing, recording. Okay, after setting targets. Okay, so after setting targets, if the error is point 0.1, point 0.2, 1, 2, 3, 4, okay, in numbers, then you have to report it to the higher authorities. Okay, it should be include variances from the targets which have been set. Okay, and lastly, there is controlling. So after getting the results from the variances, okay, which includes the number of variances, we can implement management measures to correct the errors or variances, okay, which have occurred. So controlling has different techniques. Okay, so after controlling, we can set the targets once again, and then we can rectify again, and this is a continuous process. These are the seven important elements of monitoring and targeting systems. Now we are going to see some of the important, okay, which are not included in these seven, but essential. And these seven are very important and compulsory. But these six or five elements depends on the industry. Okay. So first is checking the accuracy of energy invoices. Now here checking the accuracy of energy invoices means the energy, most of all, for example, if it is coal or thermal or fuel, okay, uh, even electricity, most of the energies are going to be purchased, or some of the energies are going to be imported from the other departments or other sectors or other nations. Okay, so invoices are nothing but the receipt of the purchase. Okay, so whatever we are going to purchase the energy from the other parts, okay, other sectors, that we have going to check. Okay, we are going to check the accuracy of the invoices. That is very important. Okay, suppose 2 kilowatt energy has been purchased from the power plant, then we have to check whether it is 2 kilowatt. Okay, we have to check the readings and we have to check the efficiency for that. Okay, now this depends on the different industries. Okay, this is not compulsory for all the industries. Next is allocation. Okay, so allocating energy cost to specific departments. Okay, now this is nothing but the budget. uh, I think you have all aware about the Indian Parliament and the budget. So each and every department like hospitality, finance, railways, and electricity and gas, etc., etc. All the departments are being sanctioned by some budgets, okay, in 1,000 crores and 100 crores, etc., etc. That is nothing but it is very similar to allocation of energy cost to department. Suppose you have an industry and there are seven departments in industry like raw material processing, then designing, then cultivating, then manufacturing, production, and end product, etc. So each and every department should be allocated some of the uh, energy cost. Okay, so for example, for raw material department, the cost per annually for the energy should be 1 lakh, 2 lakh. Okay, other department should be low or less or more depending on the uh, industry. So allocation of the energy cost to different department is also important. This can be varied from different industries. Okay, some of industries might following this or some of industries might not following it. Then determining energy performance or efficiency. This is also important. Okay, and this can be varied from different industries. Next is recording. Okay, recording energy use. So now this is also very important. Okay, you have to record like this is very similar to the recording in the previous one. Okay, so this can be ignored. And lastly, highlighting performance problems in equipment or system. Suppose in your industry there is a big machine, okay, there is a big transformer, there is a big induction motor, okay, which is having a very high energy consumption. Then you have to perform some experiments on that energy consumption, or sorry, you have to perform some experiments on the device or motor, okay, so that you can find out the different readings and you can find out the scope of future energy conservation. Okay, that comes under highlighting the performance problems in equipment or systems. Okay, so these are the 7 plus I think 4, 11 elements of monitoring and targeting system, in which 7 are very important and 4 from this depends on the industry. It varies with the industry. Okay, and next is, now here we are going to see this point in a deep manner. Okay, analyzing. Hmm? Data information and analysis. Okay, so this is the point, data and information analysis. So here in this case we are going to find out the data. Okay, data in the sense the consumption of energy. Okay, consumption of energy and the annual cost of the energy. Okay, so there is a sheet you can see, table 8.1, if you are able to see this. It indicates the annual energy cost sheet. Okay, now here you are going to discriminate between the different energies like thermal and electricity. Okay, so you have an industry, mechanical industry. In that industry you have two different energies, like you require electricity also and you require thermal energy also. So for thermal energy you require different fuels. Okay, for electricity you only require the supply. Okay, so now here for thermal energy you are going to purchase the different fuels. For example, you are going to purchase diesel, then you are going to purchase LPG, natural gas, acetylene, methylene, etc., methane वगैरह. Okay, depend upon the industry. Okay, so now I think you are aware about the types of diesel. So there are two types of diesel already. That is HSD, means high speed diesel, and then there is another one that is uh, LD, low light diesel source. Okay, LDS, HSD and LDS, light diesel source. So in case of HSD, high speed diesel, it is a kind of distilled fuel. Okay, it consists of no residuals. In case of light diesel source, it consists of some residuals or impurities. Okay, so there are different sources of types of diesels also. Okay, now here in this case for thermal energy bill, okay, fuel one might be your high speed diesel, then fuel 2 might be light diesel. Okay, Fuel 3 might be acetylene for welding purpose, for methane for different purpose, or even LPG for burning purpose. Okay, so the total rupees, okay, of total energy bill of this you can get here. Then for electricity bill, okay, you have the different options like daily kilowatt hour, okay, night kilowatt hour. Now this day is basically base load, night is basically peak load, okay, and this is the maximum demand. So maximum demand will be always higher than the day and night loads, okay. So that is, this is your total rupees, okay, in lakhs. That is the electricity bill for every month. This is for January, this is for February, March, and so on for up to December. So last column is total energy bill, okay. This is the combination of this, okay, that's the thermal energy bill and electricity bill, okay. So this column will indicate the total energy bill of your industry. After this, after finding of this Excel sheet or this table, you can go for the pie chart. Now here you can discriminate the energy cost, whatever the total energy bill will be there. Suppose 1 crore is a annual expense of your energy bill, okay, including thermal and electricity bill, okay. So you can represent in terms of percentage. So 1 crore equals to 100%, so 1% will be 1 lakh. So you can see here 45% of electricity, 45% cost has been gone to the electricity bill, then 5% for high speed diesel, okay, 12% for LPG, liquid petroleum gas, 38% for furnace oil, okay, depending on the industry. So you can find out, you can plot this pie chart, okay. After plotting this pie chart, what we are going to required is, we are going to monitor the energy, okay. So for that purpose, if you can see here, this is in terms of energy cost in rupees, okay, lakh. Electricity 45 lakh, furnace oil 38 lakh, and so on. But as we are going to conserve energy, the unit should be in energy purpose like kilo calories, etc, okay. So we need to convert this energy consumption, like suppose kilowatt hour for electricity, okay, LPG for kg, we have to convert this into kilocalorie, okay. So next step, so pie chart and energy consumption. Now here you can see the electricity unit is kilowatt hour, we all know. If we are going to convert it to kilo calorie, okay, we need to convert it for kilocalorie in order to form the data analysis, okay. So there are already given this, I'll zoom it, you can see here. Mm. If you can see, electricity 1 kilowatt is equals to 860 kilocalorie, okay. Again for high speed diesel, 1 kg of this high speed diesel is equivalent to 10,500 kilocalorie, because whenever we are going to use electricity of 1 kilowatt, only 860 kilocalories are going to burn, okay. If you are going to use some less kg, even less kg of high speed diesel, okay, number of calories burned will be tremendously high, because it is a high source of energy. Similar for furnace oil and LPG, okay, different routes for this, okay. So after this table we can find out the energy kilocalorie consumption of the different energy sources, okay. So now here, if you can compare this table, 45% of the cost was given to the energy consumption by electricity. Now here the you can see here the number has been reduced, okay, it has become 18% only, because whenever you are going to use the electricity in kilowatt, less amount of kilocalories will be burned. But in case of furnace oil, okay, if you can see here, it is already 38% here, okay. Also there is a high conversion rate for this, so it consists of most of the amount, okay, 65 60% of, okay, kilocalories. Then for LPG it is 15, and high speed diesel it is 5%, and so on. Okay, so I have written already here, 1 kilowatt equals to 860 kilocalorie. Okay, and 1 kg is 7 triple seven. I think if you are going to see this is the conversion rate for kilocalorie. So now this is the universal kg into kilocal conversion, and this is the kilocalorie conversion depending upon the type of fuel. Okay, so this is important. Okay, data, and this is data information analysis part for energy monitoring. Okay, second part. So that is for today. I think you have understood the things. These are very simple right now. After this, there are only 2 points remaining, and then the chapter will be over.